further down, and we make an incremental improvement, and then we build it with the same mistakes over and over again. And one of those mistakes is interoperability, where I literally just finished a project right now where we're trying to get four databases to talk together. And that was 3 months, vendors, three teams internally, and we barely got it done. Technology has improved over time. There's every application has an API, which is great, but that doesn't mean that those two systems are going to talk to each other. And that really is one of the main features of Ontology. And yet, Ontology has struggled to work its way into IT and application development. I'm known as the Ontology guy at work, and I built several ontologies and proof of concepts. However, none of them have actually made it into production. It's still, if you gave an architect an OWL file, they wouldn't know what to do with it. They appreciate the definition, they appreciate the structure, but they view it as too different and difficult to maintain. Yet, anytime I produce an ontology for people, they always appreciate it, and components of it always end up in the system, because it is a sound data model, it's a sound definition. So basically, I met Barry years ago, and he inspired me, Ontology inspires me, and this is really a passion project. This is me developing this in my spare time. I would love to have a user, so hopefully at the end of this I get some users and some feedback, because it's very lonely being a product manager and a customer at the same time. But I build things that are useful to me, and I hope that they're going to be useful to others. So I believe in showing and not telling. So I'm going to actually I live on the edge, and I'm a thrill seeker. This is a live demo of the production system. Again, the system is a naive ontology, so here's my disclaimer. The system is a naive ontology. It doesn't have any axioms. You can't add an axiom to anything. BFO is the top level ontology of the system, and some of BFO's axioms are built into the program themselves. So what I can guarantee you is that in the end, you'll end up with a valid ontology, a technically valid one, which means you can import it into Prodigy, and it's not breaking any logical rules. But I can't tell you that it's a true ontology, because it's naive. Basically, if I tell it that I like that humans eat chairs, it'll say that humans eat chairs. And we'll construct the logical consequences of that. So here we have BFO, and I'm going to try to put this on so I can tell you. We've just got BFO here. The system is a natural language system, so that was what I wanted, so that's what I built. We're using Google's natural language processor. And that comes with some downsides, because if I try to type in something like the word glasses, it's going to always turn it into glass, because Google's natural language processor has some limitations. The English language is very difficult. So what you have to do is you have to make simple prepositional statements. You will find some words Google will not allow in there, therefore I can't allow in there. I'm hoping to fix that this summer. I'm going to use a different natural language processor that sort of overcomes that. But we're just going to use some simple prepositional statements. I work at a food company. Response is the largest frozen food manufacturer. So we're gonna work with pizza, because I love pizza. So I'm just right now I'm just going to enter in a simple term. And again, the purpose of the system is for not specifically ontologists, but subject matter experts or different domain experts to construct ontologies in this natural language way without having to, say, have the burden of learning about OWL or maybe some of the other technical things. So Pizzalio is a chef that has bake. Sure, yeah, why not? And what do you mean by bake? It's actually pizza bake. And if I actually said pizza bake, so I'm going to say no, I'm going to say bake. And pizza bake is actually what this bake is. If I click on this pizza, you'll see that it actually is connected to a universal bake that all bakes have. But here we go. We just got this bake here. So I'm going to end this, and now I'm going to make a simple statement. Bizarre works. Pizzeria. So it's a, oh, and I spelled it wrong. It's a confirmation, you do have to spell things right. It is a confirmation system. The system, and it could be very annoying, but it's constantly asking you the same thing over and over again. But we're trying to make sure that this is exactly the thing you're talking about. So it's going to ask, is that a chef? Yes. Is work a B? No. Acquisition? No. Transform? No. End product? No. It's got a lot of works in there. So the thing is, I will let anything in there. Again, it's a naive system. So if you don't like what's there, create another one. Work as a manipulate? I'll take yes for that one. And pizzeria is a restaurant? Yes. And do all chefs work at a pizzeria? No, they do not. Do all pizzalios work at a pizzeria? I'm going to say yes. And we're going to say no. So now, if we kind of zoom in, we're now constructing, again, I'm going to call them these naive relationships, where we have the pizzalio working at a pizzeria. And, what's that? Yeah, sure. So these relationships are all either is-a or has relationships. So the is-a relationship is a subclass of. The has relationship is what I believe is the root of all other relationships. You'll see actually in a minute when we output the OWL file, it'll transform the has relationships into the appropriate VFO relationships based on what class the different objects are at. And so I'm gonna stop here. Does everyone understand the concept? You can continue to make simple prepositional statements, and it will continue to build out the objects. It'll create new objects and create these relationships. The application is doing a documentation real time, including a definition. So if we go to pizza, we're going to see all the pizzas that exist in the system, and these definitions are programmatically generated. So I'm going to just we're going to stick with our chef. And what you see is this is the URI. This is where the URIs are resolved to. We have the term, the definition, the UUID, which is universal ID, the namespace, and if there were different types of chefs, I mean, I probably should just do pizza. Let's see something there. Well, we see the schema of pizza. So these are the things that make up a schema, and there are no types of pizza, but I could add a Sicilian or a cheese or a pepperoni, and they would end up in the taxonomy. These are you can interact with all of these elements. So if I wanted to jump to food roll, I can jump to food roll and then see the different types of food rolls. If I want to generate a taxonomy, I can click the button and it's generating the taxonomy live. So if you just added a new object, it would generate that new taxonomy real time. Let's go back to pizza. Same thing with the schema. You can generate a schema file, and what you're probably most interested in is the ontology. So this is sort of, again, the base of it. These are all, you can keep interacting with these and expanding them to see what happens. Or you can click on the ontology file. And clicking on the edge. Let that continue to run. It'll resolve. It will generate an OWL file. I'm going to import it directly into Prodigy, and you'll see that it's a valid file connected. Here we go, perfect. So it generates the OWL file real time. So that means that if you just added a node, it would get there. I'm going to add caching on that so that basically you don't have to wait whatever time it takes to generate the ontology. The ontologies are, I attempted to make them as human readable as possible, but you can see already there's a lot of VFO objects and relationships connected, and it goes through and programmatically scans the scope of the tree, both vertically and horizontally, and constructs the ontology for it. So I'm going to take this file, we're going to save it. Oops. I'm not using a Max. I'm just going to save it in downloads. We have to find where downloads are. So I'm in web. I don't know how to keep doing that. We're just going to say pizza. English, of course. Not of course, always. Downloads today. I do not see. Oh, there it is. I mean, exit owl. No, I don't know what's going to happen. Hopefully Mac looks like PC. If I change the extension, will it turn it into an owl? Yeah. Use owl. I know, I'm a thrill seeker. Some people like to see car crashes, though. Am I not? It's not even giving me an error. Wow. Again, thrill seeker. What's that? What do you have? Yeah. Why am I using the web version? I can show you. Yeah, why? So just some other background. Last fall, I hooked up, I built an application that could connect to online dictionaries. And basically what that application did is it simulated an agent reading the online dictionary. So basically my Fondas was having conversations with various online dictionaries. And the purpose was, did you read it? Oh, is it there? Is that pizza? Yeah, that's it. Okay. I'm not sure. I don't know how to use this. I don't know how to use the.
You never use furniture?
I only use the web one.
Okay. Well, you got it. Yeah.
Well, could you just navigate to the visualization? Thank you. Wow. Yeah, I'm living on the edge. So basically, I built an agent to be a mediator between online dictionaries and the system. So it actually had a conversation in the background for actually several days, and actually added around 120,000 plus terms into my system. So basically, what I wanted to have was like what would the average person on the street say type of population, so that people could find the nodes. Now that doesn't mean they're correct, but my system is designed to basically be both very forgiving and also be very fluid. The system will prune and merge nodes as the human interacts with the system and tells it new information. So it's designed to be a living system. So yeah, here we go. There we go. And if you look, yeah, there we go. We have BFO. I did not lie. BFO is on the top. And can you see the relationships? Yeah. So there we go. And these are BFO relationships, Barry. I did this for you. So there you go. We got all our cheeses, all our pizzas, bada bing. What's next for Fondas? Again, I'd love to have a user. But if I don't have a user, I get up very early in the morning, and this is what I do. So what's next on the roadmap is I want to be able to consume ontologies. So this summer, we're going to be able to basically take any OWL file and basically import it into Fondas, and that will again change the structure of Fondas, thus improving the system more and more. And then the other feature that I want to start in the fall. Oh, I don't think I did that. I just want to get back to Chrome. The other feature that I want to add is the ability to consume instances. So what does that mean? It basically, give me a schema, give me a CSV file, I don't care what it is. There's also a services section. So basically you just upload an instance, which is a set of records. And basically, I've done some experiments with ChatGPT. I know some people are going to cringe at that. But if you'd say, this is a table about products, and then give me, and then here's the ontology I'm using, give me a connection between these columns in this ontology. But I want it to be certain. Basically, you construct a query like this, and it'll get about 50% of those columns. So say I had a product table, I inputted it into the system then runs that through the background. Then I say, okay, here's your columns. Are these the objects that they're related to? So get some verification. And then these are the objects or the columns that you're missing. Go through similar to the conversation we had and ask column by column. And what this will do is, again, so again, if my brain has an ontology, reality is the instance that I'm working from, this digital ontology, the real artifacts are maybe just the column records in a table. At least that's how I'm kind of treating it as. So the system will be able to look at a database or a JSON file and start making some assumptions on it, but also, again, querying the human to try to tease out what's actually happening in this table. That's a real big step, because what that will do, that's the interoperability I've always been looking for when I build applications. Now I can say, take the opportunity artifact from a CRM system like Salesforce, and I can take the marketing artifact from a system like Marketo that sends out junk emails, and join these two things together, and now say, hey, out of all the people that we have opportunities for, how many did I send junk mail to? And actually get a response. That's a real query we're working on right now. And believe it or not, it's very time consuming and difficult to do that. And it's one-off over and over again. So, in conclusion, I wanted to leave time for discussion. In conclusion, Fondas is an ontology building service. It is aimed toward subject matter experts, not ontologists. But again, you saw you can download, give this to a subject matter expert to populate, have them download the OWL file, take it in to actually work it some more, and then after the summer, upload it back into the system to sanitize it. Imagine a world in which basically everybody is participating in a real hands-on fashion in creating ontologies, getting a more vested interest, and basically, again, advancing ultimately our goals of what ontology is and what computer scientists are trying to do also. That's it. That's the presentation. That was the live demo. Got a little rough sometimes.